imaging anatomy of the lung and plura. The objective of this thoracic development, lobes and fissure, surface anatomy, tracheobronchial lines of pleural reflection and pleural recess. Development of the lung. Each lung develops from the lung bud from what we call it laryngotracheal tube. Laryngotracheal tube as a diverticulum anterior aspect of the foregut. Each lung bud invaginates through the wall of the coelomic cavity, as we mentioned in the embryonic discussion lectures. Each lung then grows to fill the greater part of the cavity so that original coelomic cavity is reduced to a slit-like space called the pleural cavity. The lung will be covered with visceral pleura. The thoracic wall will covered and lined by parietal pleura. This also demonstrated how the two layers of pleura are continuous with each other at the root of the hilar or the root of the lung. Each lung has the shape of half cone. The right lung usually has 3 lobes. The left lung has 2 lobes. The oblique fissure extend from the surface of the hilum and divide the organ into superior upper part called superior lobe and lower lobe. The horizontal fissure, the blue one, on the right lung, horizontal fissure only, pass from the anterior margin into the oblique fissure to separate a wedge-shaped part called the middle lobe from the upper lobe. There is no middle lobe in the lung, but there is a tongue-like projection of the upper lobe at the region of the heart. We call it the cardiac notch, which corresponds to the right lung. Correspond to the right middle lobe and is called the lingula. The cardiac notch is produced on the upper lobe of the left lung because of the projection of the heart at this region. Fissures. The visceral pleura clothing the surface of the lung, visceral covered whole the lung. Extend inward to line to the depth of the fissure. And we see this view showing the visceral pleura and visceral applied to them and the parietal pleura on the same time. Owing to the oblique fissure, the lower lobe lie posteriorly and inferior to the upper lobe. The base of the lung, called diaphragmatic surface, is more convex on the right than the left, and this convexity produced by the underlying the liver, thus making the right lung shorter than the left lung. The apex extends into the root of the neck. This X-ray show you the diaphragmatic surface is more concave on the right side, and this figure show you the apex of neck extend into the root of the neck. This is the CT scan. This figure show you there is a rhomboid fossa of the clavicle, maybe simulate a cavitation lesion of the upper lobe, but it is a rhomboid fossa of the clavicle. Cardiac impression on each side of the mediastinal surface has a deep concavity which accommodates the heart and thus is called cardiac impression. This impression is larger and deeper on the left than on the right because the heart projects more to the left than the right. The cardiac impression on the right is related to the right atrium. It's one of the parts and chambers of the heart. The heart contains two chambers, right and left atrium, right and left ventricle. The cardiac impression on the left is related to the left ventricle, the red one. The hilum, mediastinal surface. The hilum of each lung is located above and behind the cardiac impression. It's lying above and behind the cardiac impression. The trachea divided into right and left main bronchus or principal bronchus at the level of the menoperium sternal angle, which is an imaginary line starting from the sternal angle anterior to the intervertebral disc between the T4 and T5. Separate the superior mediastinum from the inferior mediastinum. At this position, the trachea is one of the structures which present is the bifurcation of the trachea into two main principal bronchus, right and left. This bifurcation is found at the angle of 70. The right main bronchus is 2.5 centimeters and lie an angle of 25 vertical to the vertical. The left main bronchus longer and at 45-degree vertical. This view showing the standard PA view, showing the upper half clear and needed to see the lower half and the bifurcation. Physiologic calcification of the tracheobronchial ring in an 56-year-old woman show you calcification. It's not pathological, but it's a physiological calcification. The trachea deviated slightly to the right in the lower part of its course. The right bronchus, shorter and more in line with the trachea than the left, wider and than the left. Therefore, inhaled foreign body are more likely to be found on the right side than the left side. Deviation of the trachea to the left and the principal presence of the cardiac arch or aortic arch, right aortic arch. This figure shows you variation in the bronchi branching. There is an accessory cardiac bronchus in this figure. Lobar bronchi. Each main bronchi is divided symmetrically into lobar bronchi. The right main bronchial is, as it approaches the hilum, give off an upper lobe bronchus outside the hilum, and the right main bronchus then divided into the right main bronchus divided into middle and lower lobi bronchus within the hilum. On the left side, the middle lobe bronchus is replaced by lingular bronchus. Each lobar bronchi divided into segmental bronchi. Each segmental bronchi multiply one of the bronchopulmonary segment of the lung. Within each segment there is further branch of the bronchus till it reaches the alveolar part. We then contain the duct and the sac and the alveolar. This figure on the right side show you the segmentation of the lung and the branching of the bronchi. This is what we call the bronchopulmonary segment, or roughly pyramidal in shape, and their pieces toward the apex, toward the hilum. Their bases on the surface of the lung. Base on the surface of the lung. The bronchopulmonary segment have the same name and the number as the segmental bronchi. Each segment has its own artery and vein. The vessel accompanied by bronchi and their subdivision. The artery is a branching of the pulmonary artery. The vein is a tributary of the pulmonary vein. The bronchial tree receives a blood artery, which is direct branches of the aorta, usually one on the right and two on the left. Each lobi bronchi give rise to three segmental bronchi. The middle lobe of bronchus give two segmental bronchi, and each lower lobe bronchi give 5. Right lung contain upper lobe, apical, posterior, anterior. The middle contain lateral and medial. Lower apical, medial, basal, anterior basal, lateral basal, posterior basal, posterior basal. So there are 10 segments. The apical bronchi of the lower lobe originated at the same level as the middle lobe bronchus. Left lobe, upper lobe, apical, anterior, posterior, superior lingual, inferior lingual. The lower lobe contain apical, middle, medial, basal, anterior, lateral, posterior, anterior, lateral, posterior lobe. The segments differ on the two sides only in the different position of the two segments of the middle lobe. The cardiac notch has not only obliterated the transverse fissure but has rotated the lingual middle lobe so that the lateral and medial segments of the right lung have become superior and inferior on the left side. The left upper lobe bronchi bifurcates into an upper lobe proper and lingual segments in about 80%. In 20% there is there is a bifurcation with the anterior segment bronchus coming between the upper lobe proper and the lingual below. The left upper lobe has four main bronchopulmonary segments: apical, anterior, apical superior lingual, apical inferior lingual. So we have to know that the apico-posterior bronchus quickly divided into apical and posterior. Disease of the lung, tumor, abscess may be limited to one segment before spread into another, as in this figure. A blood clot obstructs the blood flow through the branching or pulmonary artery branches or pulmonary result in infarction of the lung, means death of the lung. There will be no blood supply to the lung. The bronchogram show you apico-posterior, anterior, superior lingual, inferior lingual, and lower lobe bronchi. The bronchographic contain apical, posterior, anterior, medial, lateral, apical, medial basal, anterior, lateral, anterior basal, and lateral basal, and posterior basal. Normal variation or variety in the size of the bronchi at the bronchography depend on the degree of the filling with the low iodized oil. The duplication of the right upper lobe bronchus, the upper branches supply the apical. This variation possible. Angiogenesis of the right upper lobe bronchus, the upper lobe is supplied by the intermediate bronchus. This location located along the side of the base of the scapula, the apical segments of the lower lobe. So we can draw of any patient, can list the segment. The apical segment of the lower lobe is the most dependent part of the lung, and it lying in supine position in the bed, and the right region, where the intrapulmonary fluid may be collected in some conditions. Plura. There is peripheral, or we call it visceral plura, applied to the visceral, and parietal plura. Unlike the parietal plura, the visceral plura deep into depth into the lung fissure. Therefore, in the fissure, the vessel of the plura are not adjacent lobes, lie in contact with each other. Think of even number. The cervical plura extend into the neck, 2 centimeters above the medial third of the clavicle. From the neck, the plura passes behind the sternoclavicular joint, reaching the midline at the level of second costal cartilage. From the sternoclavicular joint, the two pleura from the sternoclavicular contact as far as the fourth cartilage. At the level of the fourth costal cartilage, the right pleura continue vertically down to the sixth cartilage. The left pleural arches laterally at the level of the fourth costal cartilage and descend laterally to the border of the sternal cartilage down to the level of the sixth costal cartilage, at which the level of the pleura on both sides passes around the chest and will cross till the 8th week, and by crossing by the mid-clavicular line and 10th line, the rib at the mid-axillary line. Let's show you the diagram and show you the picture. The pleural passes across the 12 ribs and the neck. The lung marking corresponding to those of the pleura about 2 ribs higher in the lower part of the thoracic. The lung marking correspond to those of the pleura, but are 2 ribs higher in the lower part of the thorax. During full inspiration, the lung fills the pleural cavity. During quiet inspiration, there are 3 sites where the lung does not fully occupy the pleural cavity. The site where the parietal pleura come in contact with each other with the parietal pleura, all called recesses, pleural recesses. The pleural recesses are only occupied by the lung tissue during the full inspiration. There are the right and the left costodiaphragmatic recesses, right, left costodiaphragmatic recesses, and the costomediastinal recesses between the notch of the heart or between the part of the heart and the sternum. There are the right and left costodiaphragmatic recesses and the costomediastinal recesses. Is located at the inferior margin of the pleura. The region, the costophrenic angle, excess fluid in the pleural cavity with causing an opacity. So excess amount of fluid causing opacity, maybe single or both, or opacity which obliterate the angle of the oral cavity. Costomediastinal recesses lie along the anterior margin of the pleura at the cardiac notch, in the anterior border of the left lung, where it overlies the heart. The recesses lie at the anterior end of the 4th, 5th intercostal space, and during full inspiration it becomes occupied by the lingula of the left lung. This figure of X-ray shows you the fluid extends, and by gravitating toward the costomediastinal recesses, that it obliterates the costophrenic angle. Pleural effusion, accumulation of more fluid than expected, and tend to collapse the lung, and because of the presence of them, so it will prevent its expansion. Thank you for your listening.